So what do we do to work this one out? Well, this is going to be just our simple interest formula. I equals PRT. Do we know I? I, of course, is the dollar amount of interest, and that is the 105. Do we know P, the principal, the dollar amount of the principal? That is 3,500, 3,500. Do we know R? What is the rate of interest? R is what we are looking for. And T is the time, that's 6 months. Now our time must always be listed in years. So 6 months becomes 6/12. So now before we solve the equation, we're going to combine what we can. So we have the 3,500 and the 6/12. 3,500 times 6/12. If you didn't want to use the fractions, like I said, just do 3,500 times 6 divided by 12, which is going to be 1,750 times R. Now, R has been multiplied by 1,750. So to solve our equation, we are going to divide by 1,750. So 105 divided by 1,750 is 0.06. So our rate is 0.06, which means the percent is, move the decimal over 2 spots, 6%. So they are earning 6% interest. Any questions on that? Okay. So while we're at it, I want to review the U.S. rule for partial payments because that is one of the more difficult topics that we covered last time. So just want to do one quick example of that. So let's say that on July 13th, Pete borrows $6,200 at 9.3% for 90 days. On August 11th, he makes a partial payment of $2,100. On September 9th, he pays another $2,000. So find the balance due and the total interest. So I'm going to give you a couple minutes to try that in your notes. Well, let's see how far you made it on this one. So the first thing we need to do is we need to find our dates. And I already looked them up in the table. July 13th is day 194. August 11th is day 223. And September 9th is 252. Those all look right to you guys? Okay. This time of night, my eyes tend to jump lines on the table. So then our first action is on August 11th when Pete makes the $2,100 payment. So we need to figure out what day that is. So August 11th is 223 minus July 13th is 194. That subtracts to give us 29 days. So we got to figure out our interest for 29 days. So I equals our principal of 6,200 times our rate of 0.093, that's from the 9.3%, times 29. This is over 360 or 365? Well, if it's not stated, we always use ordinary interest, which is 360. So 6,200 times 0.093 times 29 divided by 360. $46.45 is our interest. So before we make our payment, that interest gets added in. So our balance before the payment, $6,200 plus $46.45 is $6246.45. That is our balance before the payment. Then we're going to subtract the $2,100 payment, which will give us $4,146.45. So now our next action here takes place on September 9th, which is day 252. That's a $2,000 payment. So I'm going to do 252, and our interest is current up until the August 11th, which is 223. So we have gone 29 days again. It appears to be 29 days again. So now we're going to figure out our interest. Our principal, though, is now $4146.45. Our interest is still 9.3, so 0.093. And it is 29 over 360. So 4146.45 times 0.093 times 29 divided by 360. 31.06. So $31.06. So that gets added to our balance. Before the payment gets made. So $4,177.51 is the balance before the payment. We're going to subtract the payment of $2,000. $2,177.51 is the balance after the payment. Well, now then, nothing else happens until the end of the loan. So we have taken up 29 and 29 days. That is 58 days. Out of, this was a 90-day loan, wasn't it? I hope. For 90 days. So we're going to do 90 minus 58 is 32 days left. So we're going to calculate our interest for the remaining 32 days. Well, our principal is now $2,177.51. Our rate is still 0.093. It's now 32 days over 360. So 2177.51 times 0.093 times 32 divided by 360. $18 exactly is the interest. So we're going to add that on. $2,195.51 is our balance before, or that's actually our balance at the end. That is our outstanding balance, our balance due. And then we need to add up all of our interest charges, which is the $18, the $31.06, and the $46.45, which comes out to be a total interest $95.51. Sound right? Did anybody get that far? Anybody get done and get that answer? Just ran out of time? Those are a little bit long. So what we've been talking about here are what we call simple interest notes. At the end of class last week before we left, we mentioned something briefly called a simple discount note. And a simple discount note was a little bit different. Let's do a little comparison here between the simple discount and the simple interest. So, face value. In the simple interest note, that is your principal that you start with. For a simple discount note, it is still your principal, but it is what you pay back at the end. In other words, it's equal to the maturity value. For both of them, the interest is PRT. For the simple discount note, the maturity value is the face value, or the principal. For the simple interest note, the maturity value is the principal, the face value, plus the interest earned. On a simple discount note, we have to define something called the proceeds. The proceeds on a simple discount note are equal to the principal, or the face value, minus the interest. And the interest is what we call a discount. The difference between interest and discount. Interest is added onto the note to increase the balance. A discount is taken out of the note before you receive the money. So let's look at how this works. Let's say Pat borrows $4,000 at 8% for, let's do 120 days on a simple discount note. Now, I'm not going to ask any questions here. I'm just going to go through this whole situation and define everything in it. So obviously the face value here, the defined amount of the note is $4,000. Now from that face value, we're going to define a discount. The discount is going to equal the interest, which is going to be our principal of $4,000 times our rate. 8% is 0.08. 120 days. Now it does not specify ordinary or exact interest, so we assume ordinary. So our interest is 4,000 times 8% times 120 over 360, giving us $106.67 interest. Now I realize on my calculator I left some numbers off. I was just shortening it up when I entered it. So $106.67 interest. That is the amount of the discount. So what that means is our proceeds in other words, what Pat actually receives is equal to that face value of $4,000 minus that discount of $106.67. So Pat is going to actually receive $3,893.33. Maturity value. $4,000. Pat will pay back $4,000 at the end of the loan. So the difference is what they're doing in the simple discount note is they're deducting the interest from the principal before they give it to you. Now you might be thinking that's a weird way of doing it, but there are a couple of reasons why. One is essentially the bank gets more interest. Now I'll go over why that's true here in just a second. Second is if you have a guaranteed income coming in, you're borrowing against that amount. So the bank says, okay, you're going to have this much money to pay us back. Here's how much money we're going to give you, which is the proceeds. So they're going off of what your ability to pay back is going to be, and then discounting that to give you an amount that's slightly smaller than that. So let's take a look at another example. Tim borrows $6,000 at 9% for 180 days on a simple discount note. Find the discount and the proceeds. So our discount, again, is just the amount of the interest. So the discount is equal to the I in our simple interest formula. So it would be the principal, $6,000, times our rate, 0.09 for 9%, and our time, 180. Again, it doesn't say exact, so we're going to assume ordinary over 360. Which, what is that, $270 in interest and discount? So that is the discount right there, $270. The proceeds are going to be that face value of $6,000 minus the discount of $270. So $5,730. That is the proceeds. So let's say Chris borrows $5,000 at 8% for 90 days on a simple discount note. SDN, simple discount note. Find the discount and the proceeds. I'm going to give you a couple minutes to do this in your notes. So find the discount. That's the amount of the interest, so it'll be 5,000 times 0.08 times 90 over 360, which is what? $100? How many came up with $100 for the discount? Perfect. So then for the proceeds, we take that face value of 5,000 minus 100. Chris actually receives $4,900. So the next step here is to realize the bank is saying that this is 8% interest. It's an 8% discount, but the actual interest rate is higher than that. The effective rate is higher than that. Because the 8% is figured off of the $5,000, but you do not get, in this case, Chris does not get $5,000. Chris only gets $4,900. So the effective principal here, if we're viewing it like we would a simple interest note, is only $4,900. So we can go through and calculate the effective rate using our simple interest formula. The amount of interest is the discount. Our principal, $4,900, is the proceeds. And we are trying to find an effective rate. And our time, of course, is still 90 over 360. So our first step in solving this is going to be to combine 4,900 and 90 over 360, which is what? 4,900 times 90 divided by 360 is 1,225. Does that work? So we have 100 equals 1,225 times R. So to solve for R, we're going to divide by 1,225. So 100 divided by 1,225. Gives us 0.0816. That's our rate. Now I have to move my decimal point to make that a percent. That's 8.16%. Now in this case, I did not specify whether I wanted it rounded to the 10th of a percent or 100th of a percent. It would be one of those two usually. My math lab will always say usually round to 2 decimal places, or to a percent to 2 decimal places, or round to the 10th or 100th of a percent. So the effective rate here, even though it states it's an 8% interest, it is actually 8.16% because you do not receive the full amount of the face value. So let's look at another one. Dave borrows $7,000 at 10% for 180 days on a simple discount note. Once again, actually we're just going to look for finding the effective rate. So to find the effective rate, of course, we do have to find the discount and the proceeds. So let's find the discount. The discount will be 7,000 times 0.10 times 180 360. $350 is the discount. Proceeds is simply going to be our face value, 7,000 minus the discount of 350. So $6,650. So now that we have all that, now we can look at finding the effective rate. I equals PRT. What is going to go in here for the interest? The amount of the discount, which is $350. What's going to go in here for the principal? Will it be the $7,000? Say no. No. It's going to be the amount that you actually receive, which is $6,650, the proceeds. Now, R is the rate. That's what we're looking for. T, the time, that doesn't change. That's still 180 over 360. So we're going to go ahead and combine. 6650 times 180 over 360 is 3,325 times R equals 350. And we will solve by dividing by 3,325. That'll be R by itself. So 350 divided by 3,325 is 0.10526. When I'm doing my rate, by the way, I usually try to go to 5 decimal places. That way, once I move my decimal point, 1, 2, at 10.526%, now I can look at the problem and round it. If it's rounded to 1/10 of a percent or 100th of a percent, I still have enough information here to do that. If I ask for this to the nearest 100th of a percent, the 100th place is there, but the 6 tells me I have to round this up to 10.53%. So usually 5 decimal places here is pretty safe in your rate. Well, we're going to have you guys try an effective rate calculation. Mike borrows $12,000 at 11% for 120 days on a simple discount note. Find the effective rate. I'll pause. Where do we start? Well, before we can know anything, we have to find the discount, which is our interest, which is found using $12,000 principal times 11% is 0.11 as a rate times 120 over 360. So at $440, how many came up $440 for the discount? Good deal. So for the proceeds, it's just $12,000 minus 440 is $11,560. Now we can find the effective rate. The interest is going to be the amount of the discount, $440. Our principal is now going to be the proceeds, so $11,560 instead of the $1,200 or $12,000. Our rate is what we're looking for, and our time is still 120 over 360. So the first thing we have to do is we have to combine the 11,560 and the 120 over 360. Which gives us $3,853.33. Now, notice I did not hit clear on my calculator because since this is a continuing decimal, a repeating decimal, 1/3, if I write it down and punch it back in, it's going to be rounded off. So I want to keep it in the calculator. So to solve this, of course, I have to now divide by that $3,853.33. So to divide the $440, what I'm going to do is I'm going to take 440 divided by, and then I'm going to use that answer function. So second, ANS, most of all your calculators should have it down close to the equals key. Enter. I get 0.11419. 0.11419 is my rate. Now I didn't tell you where to round this to, so we're just going to assume it's to 100% again. So I move it over 2 spots. That's 11.419% to the 100%. There's my 100th place. The 9 tells me to round up to 11.42%. How many of you had 11.42? Cool. Anybody not sure how to get that wants me to go over another example? Okay. Well, as I said, one of the places we use simple discount notes is when you know you have money coming in, or a certain amount of money coming in. And one of the ways you do that, one of the times you do that is when you've extended credit to someone else. For example, let's say that I have a customer that bought merchandise from me on invoice, and it gets to the end of that credit period and they still cannot pay off their invoice. Let's say they have an invoice of $8,000. We'll just keep it simple. So what I do is I tell them, look, I'll give you another 90 days to pay, but I'm not going to do it for free anymore. You can have that extra 90 days to pay, but I'm going to charge you 12% interest. So what that means is at the end of the 90 days, the maturity value is going to be that amount, that $8,000 plus interest. So the amount of interest is going to be the $8,000 times the 12% times 90 over 360. Is that $240? Somebody double check me. I believe that's right. That's my interest. So then the maturity value is the $8,000 plus $240 in interest, $8,240. So at the end of 90 days, you will have $8,240 coming in. Now here's where the discounting the note comes in, or the discount notes come in. Let's say that at day 34, you need money for something. You know, maybe you have a bill due that you need to pay, or maybe you just don't feel like hanging on to the note anymore. But for some reason, you want money. You want to get the cash out of this. You don't want to hold on to the note any longer. This is what a lot of banks do, by the way. If you take out a home mortgage, they don't actually hold the mortgage. They discount it or sell it to someone else. Now, the way the textbook writes this, the textbook basically writes it up as though you are going to the bank and the bank is buying this note from you. And that is not technically what is happening. What is happening is you are going to the bank and you are telling them, hey, I have this $8,240 coming in. at the end of the 90 days. It's been day 34 now, so in another 56 days, that's coming in. So can I borrow against that right now? And how much will you give me? So what you're doing is you're giving the bank now has the right to collect that amount, the $8,240. The bank is going to give you a loan based on that. And it's going to create something called a contingent liability. What that means is, even though the bank now has the right to collect that money from the person who owes you, if that person doesn't pay them, you are still responsible for it. Because technically the bank does not have a contract with that person. The bank has a contract with you. So you are responsible for that money getting paid. The bank will try to collect it from them, but you are responsible for that money getting paid no matter what. So what is really happening here is you are going to take out a simple discount note. From the bank with a face value equal to the maturity value of the other note. So basically, you're just taking out a loan from the bank. The difference between you just going to the bank and taking out a loan and what's happening here is the bank will try to collect it from the third person. But again, you are still the one responsible for it. Okay, this looks like a great spot to take our break. So let's do that. When we come back, we'll actually start going through some of the math involved in these simple discount notes. So it is about 6:18 right now. We'll come back at 6:28.